The textbook doesn't cover this in lesson 96, but I'm going to actually show you how to use scaling. And this all has to do with your A term. You know, what is the value of A? That A determines the shape of the graph, and so that shape of the graph is going to be a big deal. All right, so the shape of the graph, and what do I mean by A?
The term in front of x.
Yeah, it's the term in front of x squared. F of x equals, let's remind ourselves, f of x equals ax squared plus bx plus c is what we're talking about when we're talking about a quadratic expression. And your highest exponent in any polynomial function always determines the shape of the function. These other terms have some effect on it, but the shape is always determined by your highest exponent. Okay, and the highest exponent is directly affected by A. If A is positive, we open up. If A is negative, we open down. We already know those two things. We're going to learn a little bit more about what A does today, and that's what I mean by scaling. So when we're talking about scaling, we're talking about what A does. We'll kind of look at that through the context. And we're going to find the vertex, the intercepts, and then we're going to use scaling a little bit to determine the shape and how to graph a quadratic expression. Okay? Now, let's move on to some important concepts. Golly, I'm having some major malfunctions here. Finding the vertex and axis of symmetry algebraically. Now, here's the formula. And we've already determined how to find the vertex graphically. That's why you find your maximum or your minimum value for your function. It's a maximum if the parabola opens down. If A is negative, we have a maximum. We find a maximum. If A is positive, then we're opening up and we have a minimum. And the vertex occurs at the minimum value, or the minimum value occurs at the vertex, or the maximum value occurs at the vertex. So we found that. What we want to do is find it algebraically today. All right, the vertex of a parabola is, our x-coordinate is always negative b over 2a. That's the x-coordinate. The y-coordinate, got to write this. The y-coordinate is the function evaluated at that point. So you plug in that point into the function in the place of x, and then what comes out is the y value of the vertex. Brent?
I thought the X thing was already used like something else. Like maybe we would actually.
It's the axis of symmetry. The axis of symmetry, the vertical line that splits the parabola into two symmetrical parts, is x equals negative b over 2a.
I thought like we used that formula or something.
You may have heard Jackson's talking about it because they've been mentioning some in class, but this is the first time I've shown you guys this. I think
you talked about it, but it didn't show us.
so. I did cover this a few lessons ago. I didn't remember if I had or hadn't. I knew that we were talking about it at least informally at some point. To find the y-intercept, how do you find the y-intercept of any function?
X has to be 0.
Yeah, you plug in 0 for x. X equals 0, and that will give you the y-intercept. That just gives us another point. Now, the only thing we've done up to this point to graph quadratic functions is pick a bunch of x's and plug them in, and then you get y values out. Okay? This is one x value that we can always plug in and get a point really quickly. You can do it by observation in most cases. Okay, let's use these 2 points, or let's use these facts, the vertex and the axis of symmetry, to get some kind of idea of what this graph is going to look like in the y-intercept. So again, this is in standard form, right? Y is f of x.
I think you went too far.
I did. Thanks. Y is f of x equals, and it's ax squared plus bx plus c. What's our a value in this problem? 1. What's the b value?
4.
4. and the c value is 5. So we have our quadratic term, our linear term, and our constant term. Okay? If we're using the axis of symmetry formula, the axis of symmetry occurs at x equals negative b over 2a, which in this case is negative 4 over 2 times 1, which is negative 2.
Where'd you get the 2 times 1 from?
All right, the formula has a 2 in it, and my a value here is positive 1. Hold on just a second. Now, I want to evaluate the function at negative 2. So this is the x value where the vertex occurs. It's also the axis of symmetry. So to find the function value at negative 2, we put a negative 2 everywhere there's an x. What does that give us? 4 minus 8 plus 5 is positive 1. All right. So my vertex is negative 2, 1. Which direction does this parabola open?
Upwards.
It opens up. How do we know that?
Because the number in
X
front of
squared
the
is
A is.
positive.
Yeah, so x squared is positive. All right. Now, negative 2, 1 is the vertex, so I'll come over to negative 2, 1. You should be writing or working on this, not standing and watching or sitting and watching, paying attention. It opens up. I need another point.
5, 7.
All right, let's find the y-intercept. The y-intercept is where what? X equals 0. If I plug zeros in for x here, what do I get? I get a 0 there. I get a 0 there, and I'm left over with a 5. So my y-intercept is at 0, 5. So come over 1, 2, 3, 4, 5. It's there.
Wait, what?
You just put 0 for X, so you got 5 for
Okay.
Okay?
Mhm.
So it opens up there. And because this line is the axis of symmetry, right through the middle is symmetric, watch this. Now I want you to watch carefully. From this point to my y-intercept, what did I do? From the vertex to the y-intercept, I went over 2 and up 1, 2, 3, 4. Right? You went over 2, over 1, 2, and up 1, 2, 3, 4. Because it's symmetric on this side, we would also have to go over 2. So over 2 and up 1, 2, 3, 4. And there's another point that tells me where it goes on that side. So that's what the graph of this looks like. And we can get that just by finding the y-intercept and looking at the symmetry of the graph. Does this have any zeros?
No.
Because zeros are what?
X-intercept.
X-intercepts. Now, incidentally, this is kind of an algebra theory thing here. Can x squared plus 4x plus 5 be factored? Are there any factors of positive 5 that add up to be positive 4?
No.
No.
No. 5 and 1 add up to be 6 or negative 6.
That's prime.
It's prime, and it doesn't have any rational zeros. Okay? And there's a relationship between those two things. If it can be factored, then we're going to have rational zeros. What do we mean by rational? Integers are rational, but so are fractions and good decimals, right? Anything that can be written as a fraction is a rational number. So we're going to have rational x-intercepts or rational zeros if it can be factored. If it can't be factored, then we have, in this case, imaginary zeros. There's no real zeros. The x-axis is the real x-axis. Yes, real number axis.
So if you don't think something can be factored, graph it if it doesn't touch the x-axis.
If it doesn't touch the x-axis, it certainly can't be factored. That's correct. Did everybody hear that? Because that's the extension that I want you to make. If you're trying to factor something, and it doesn't touch the x-axis, that means it can't be factored. But sometimes it will touch the x-axis and it still can't be factored. Okay?
It's a prime number.
If your x-intercepts are irrational, then we can't factor it over the rational numbers.
Definitely.
Certainly can't be factored. It's not a factorable polynomial in the real numbers. Okay? There are two imaginary zeros to this, so this expression could be factored in the complex numbers, but you wouldn't do that until you got into a graduate school math class, complex analysis. Yeah, George?
What if it only puts the x-axis on?
Then it only has one zero and it's a perfect square trinomial. Okay? And we'll deal a little bit more with that as we continue to discuss this. Now, here we go. Next one, y equals 3x squared plus 18x plus 13. I want to deal with this one exactly the way we just did the last one. We're going to find the vertex. We're going to find the axis of symmetry. We may find another point using the symmetry of the graph. But let's start off by finding the axis of symmetry and vertex. The axis of symmetry is going to be negative b over 2a. Always write the formula. The best way to memorize the formula is to write it every time you use it. The value of b in this problem is 18. So negative 18 over
2 times 3.
2 times 3 is 6. Negative 18 divided by 6 is
Negative 3.
-3. So that's the x coordinate of my vertex, and it's the axis of symmetry, the vertical line that splits the parabola into a mirror image of itself. Now, what do I do with that to find the y coordinate of the vertex?
You gotta plug it in.
Plug it in.
You plug it in, that's right. So everywhere there's an x, I'm going to use function notation. The function evaluated at -3 is equal to 3 times -3 squared plus 18 times -3 plus 13. Now you can use your calculator to do this. Make sure you use parentheses. Okay. What's 3 times -3 squared?
27.
27. 18 times -3 is -54 plus 13. And this is
Negative 14.
-14. Man, I don't want to graph that on a graph here, but. So my vertex here is at -3, -14. That's a bunch of little ticks, right? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Way down here. It opens up because A is positive. What else could we figure out really quickly? The y-intercept is x is 0, y is 13, right? If you plug zeros in here, these go away and you're just left with y equals 13. So 0, 13, that's way up here the opposite direction. So what do you notice is really a lot different about this parabola? It's very stretched, right? There's 0, 13. I'm not going to count them, but there it is.
So this
Do what?
does 0.
It has zeros. I don't know if they're rational or not. I don't think they are. Can this be factored? What's 3 times 13? It's 39. Are there any factors of 39 that add up to be 18? No. Right? So this has 2 zeros, but they're not rational numbers. They're irrational numbers. And we'd have to find them using a different technique that we haven't learned yet.
Hey, so if the book asked us like to find the zeros, like this,
Yeah.
we would just say no
If the
zeros?
book tells you to find the zeros, they're either going to give you a graph where the zeros are labeled, or they're going to want you to use your graphing calculator like we've done before, or it'll be factorable a little bit later. So let's talk about what happened here. I went up from here from this point, the vertex point was negative 3, 14. So if I go over 1, 2, 3, I go up 27. So if I went 3 the other direction, I'd have another point over here on the other side of this symmetry line that would be negative 6. This point would be negative 6, positive 13. So this parabola is very stretched vertically, right? So it looks like this. It's really skinny.
It's not vertically changed.
It's not vertically challenged, that's correct. That was almost funny, George. Well done. All right. So that's what the sketch of the graph would look like. Now here I want to talk a little bit about scaling. Okay? So let's go over to our, just a side note here. And I need to take all this off. Y'all are good with that? Let's look at y equals x squared and y equals 3x squared. And let's look at a quick table of values, x and y. I want you to see what the 3 does to this thing. Now, in this problem, y'all pay attention to what's going on here.
You want us to write that down?
In this problem, I do want you to write this down. In this problem, the vertex is 0, 0, right? Negative b over 2a. What's the value of b in both of these? What's the value of b? 0. So the opposite of 0 over 6, or the opposite of 0 over 2 is going to give you 0. And if you plug 0 in, right here in the middle of both of these, you have 0, 0 as your vertex point. Now let's take on some negative values, and let's take on some positive values, and see what happens here. Okay, now, what's negative 1 squared? What's negative 2 squared? 4. What is positive 1 squared? Positive 2 squared? 4. Same thing here, right? Because if we square, no, I'm sorry, these are not the same. Because we're multiplying it by 3. Negative 1 squared times 3 is 3. Negative 2 squared, or negative 2 squared times 3 is 12, right? Not negative 12. And this would be 3 and 12 because of the symmetry. Okay, what does the parent graph do? We called this the parent graph a few lessons ago. If you go over 1 from the vertex point, you with me, Jay?
Yes, sir.
From the vertex point, if we go over 1 to negative 1 or positive 1, we go up 1, right? And if we go over 2, what do? We go up 4. If we went over 3, how far would we go up? 9. What are those? What's 1, 4, 9? They're perfect squares, right? All right, on this other side, if we go over 1 from the vertex point, we go up how many?
3.
Which is our normal stretch multiplied by 3. If we go over 2, instead of going up 4, how many do we go up?
12.
Which is 3 times 4, right? And if we went over 3, we would go up, instead of 9, we go up 3 times 9, which is 27. Okay, so back to that problem that we just worked. Yes?
Need for Brent Hopkins to stop by and see Ms. Mahoney when the bell rings.
Okay.
Thanks.
All right, so in this problem, what do we have for our vertex? We had vertex was negative 3 and
Negative 14.
negative 14. So if I go over 1, I would have negative 2, and I go up 3. Right? What's up 3 from negative 14?
Negative 11.
If I go over 2, I'd go up,
Another 3.
I'd go up 12. I wrote 12. So up 12 from here would be
Negative 8.
negative 2. So we can get points by scaling. Okay? If I was dealing with y equals something that has a 2x squared, and I want you to notice that these two numbers only affect where the vertex is. That's the only effect they have on the parabola. The shape is completely determined by the 3x squared. If you plug those values in, you're going to go over 1, you're going to go up 9. And that's over 1 in each direction. Over 1 in each direction, we're going to go up 3. Over 2 in each direction, we're going to go up 12, excuse me, because 2 squared is 4, and 4 times 3 is 12. So we can use scaling to determine that. And we'll revisit this. I can see some blank looks. Let's look at this one. What's this one going to do? If we're just dealing with 5x squared, it goes over 1. Instead of going up 1, it's going to go up 5. If we go over 2 from the vertex, instead of going up 4, it's going to go up 20. So it's really being stretched quickly. But what's the vertex? X equals negative b over 2a. That is
Negative, what was it again?
0 over 10, right?
Oh, yeah, there's
4 is the c value. The b value in this parabola is 0. The linear term, ax squared plus bx plus c. Because there's no x, there's no b. Well, actually, there is a b, it's 0. All right, so x is 0. Function evaluated at 0 is 4. So my vertex is
0, 4.
0, 4. I'm going to use my scaling real quick. 0, 4. 1, 2, 3, 4 is my vertex point. If I go over 1,
it'll go.
I'll go up 5. So from this point, I would go over 1 and up. 1, 2, 3, 4, 5 right there. Both sides because of the symmetry. So this one's really, really skinny. It opens up like that. Does it have any zeros? No zeros. Imaginary zeros only. No real zeros. All right. Let's have a look at these. Find the zeros of this function. The zeros are the x-intercepts. So the x-intercepts are where y is equal to 0. We could do this graphically, but let's do it algebraically. Let y equal 0. Will the right side factor? What will it factor as?
X minus negative 3 squared.
Not minus negative 3.
I mean, minus 3.
X minus 3 squared. How can I make this equal to 0? What value would make that equal to 0? 3. X equals 3. So we only have one x-intercept here because it's a perfect square trinomial. So Savannah, you asked earlier, will it ever have one x-intercept? And yes, the parabola could sit right on the x-axis, and it only has one x-intercept, and it's x equals 3. Okay? Let's look at another one.
Wait, what?
The zeros are the x-intercepts, and the x-intercept occurs where y equals 0. Can I factor the right side?
Yes.
Yes.
What is the factorization of x squared minus 3x minus 10?
X minus 5 times x plus 2.
X minus 5 times x plus 2. What value would make this 0?
5.
X equals 5.
Or negative 2.
And what makes this 0?
Negative
Negative 2.
X equals negative 2. Those are my two x-intercepts. Now, how can I use the x-intercepts? They're the zeros, right? So I could use the x-intercepts to graph. So I could find the vertex of that thing real quickly. I could see that the y-intercept is negative 10. The two x-intercepts, I got 4 points. That's plenty enough to determine the shape of the graph. Yes?
Well, did you not have two vertexes? Did you have two different x's?
No. Those are zeros, not vertices. The vertex is at negative b over 2a. Now, y'all listen. that one right there, you're gonna have to find the zeros of that one using your graphing calculator because they aren't rational. All right, we'll finish this tomorrow, but there's your homework for tonight. 642, A through F, 1 through 9, 11 through 16. This will be for accuracy.